At noon on August 11th, 2026, Earth gets rings. Above a dry mountain observatory, a monumental band of bright rock cuts the blue sky while its shadow divides the sunlit ground below. The ring stretches from 9,500 to 18,000 kilometers from Earth's center. Ordinary rock now occupies a vast region of orbital space. Near the equator, it looks like a brilliant line. At middle latitudes, it opens into a broad arch. Farther north and south, it sinks toward the horizon. Some spacecraft will survive beneath it, others will cross it at several kilometers per second and disappear into expanding clouds of debris. Its shadow will not stay at the equator. It will migrate with the seasons, weakening near the equinoxes and spreading farthest near the solstices. Within months, satellite routes change. Within years, harvests and weather respond. Within generations, cities are designed beneath a permanent second horizon. The surprise is not that the ring ends the modern world. It is how much of that world survives, altered by one unavoidable band overhead. And the deepest change may begin when people stop asking where it came from and start deciding what life beneath it should become. There is no impact. No moon breaks apart above us. Gravity has not changed, and the oceans do not leap from their basins. The ring is the one impossible gift. It simply exists at noon, dense, optically thick, rocky, and trapped in Earth's equatorial plane. Everything that follows must obey the same physics that governed the planet 1 second earlier. At the observatory, the first response is silence. The individual rocks are too distant to see. Together they form a surface. Silver in places, ochre in others, streaked with darker lanes where the material is thinner. The band seems solid until its edges tremble in the heat rising from the mountain. One side shines in direct sunlight. Another section enters Earth's shadow and turns charcoal gray. The darkness travels around the ring, not like a cloud, but like night moving across a landscape in space. Phones rise. Traffic stops on mountain roads. Pilots report a structure spanning the sky, although nothing has entered the atmosphere. Emergency lines fill with descriptions of an object that is everywhere and cannot be approached. Clouds hide it over some cities. Millions of people first encounter the ring indirectly, through live video from somewhere with clear weather. Then a cloud breaks, and the new sky is waiting behind it. At the equator, people expecting Saturn see something stranger, a thin, almost blade-like line passing from horizon to horizon. At middle latitudes, the same ring displays its immense upper surface. Toward the poles, it becomes a low wall of light. The first global argument concerns what everyone can see. The first global emergency concerns what nobody can. Spacecraft do not encounter a majestic continuous floor. They encounter stones and dust moving at orbital speed. Anything already traveling through the occupied region faces repeated collision opportunities. A grain can pierce shielding. A larger fragment can break a satellite apart. Each destroyed spacecraft adds metal, insulation, and solar cell fragments to the natural debris, making dangerous crossings more chaotic. Some satellites vanish within minutes. Others complete several apparently normal circuits before reaching the place where their orbit cuts the ring. Controllers watch healthy telemetry end in the middle of a sentence. Yet the entire orbital economy does not blink out. Many low-orbit spacecraft circle below the ring's inner edge. Weather satellites, imaging constellations, and crewed stations in sufficiently low paths continue around Earth. Farther out, navigation satellites and geostationary communications platforms may also remain beyond the ring. The trap lies between them. Highly inclined or elongated orbits can cross the equatorial plane inside the rocky band. Transfer routes that once carried new satellites outward may now pass directly through it. Space beyond the ring still exists, but the familiar road to reach it has become a firing range. Mission planners begin drawing new routes on the first night. Rockets can climb away from the equatorial disk, use steep inclinations, and cross its plane beyond the dangerous radii. That demands more fuel, different launch directions, and longer journeys. some payloads become too heavy or too expensive for their old launch vehicles. Equatorial spaceports lose part of the advantage that made them valuable. Northern and southern sites gain new strategic importance. Governments negotiate emergency flight corridors over oceans. Insurers stop pretending they understand the risk. The ring has not imprisoned humanity on the ground. It has made every passage outward narrower. On Earth, navigation continues, because major systems occupy more than one kind of orbit, and because aircraft still have inertial instruments, radio beacons, and human controllers. But failures arrive unevenly. A ship keeps its position while a survey crew loses precision. One television service survives while another depends on a satellite that had to cross the disk. The modern world discovers that space was never one place. It was a collection of roads at different heights. Now some roads end in stone. The ring's most important effect on the ground is not the light it adds to the night, it is the sunlight it removes from the day. Because Earth is tilted, the sun does not remain in the ring's plane throughout the year. Near an equinox, sunlight approaches almost edge-on to the disk, and the ring casts relatively little shadow across the planet. As the planet moves toward a solstice, the angle opens. The broad face of the ring intercepts more sunlight, and a shadow develops in the winter hemisphere. This is not an eclipse racing across continents. It is a seasonal belt whose edge advances over days and weeks. In June, the shadow leans into southern latitudes. In December, it reaches north. Its precise width depends on the ring's thickness, opacity, and structure, but the direction is unavoidable. A disk fixed above the equator must cast a moving shadow on a tilted world. The first communities to enter it watch the change arrive on weather satellites and solar forecasts. The morning is normal. By afternoon, the landscape seems to have been viewed through smoked glass. At the shadow's edge, one hillside remains bright while another darkens. Solar farms report falling output beneath clear skies. Pavement cools. Birds respond as if a storm has arrived, although the horizon is empty. Then the boundary continues onward. The ring does not create permanent equatorial night. It does not freeze the same country all year. Near the equinox, the great shadow retreats. Regions that spent weeks under diminished winter light return to ordinary sunshine. That return becomes the first reversal of the new world. The ring can seem like a ceiling, but its shadow behaves like a season. And seasons can be measured, anticipated, and remembered. Sunlight is the engine beneath weather, harvests, and ocean circulation. The ring has placed a variable shield in front of that engine. One published climate experiment studied an opaque equatorial debris ring around modern Earth. In that particular model, the ring reduced the global average incoming sunlight by 17.6 watts per square meter. Its seasonal shadow reached roughly 13 degrees of latitude at maximum. Those numbers are not a forecast for this ring. Change the geometry or opacity, and the result changes, but the experiment reveals the scale of the question. Reflect tropical and subtropical sunlight before it enters the atmosphere, and the response does not remain beneath the shadow. Land cools faster than oceans. Winds adjust to new temperature differences. Rain belts move. Some monsoons weaken or arrive late. Others may shift rather than simply disappear. Ocean currents carry the disturbance beyond the darkened latitudes. The first year is mostly confusion. A failed crop cannot yet be separated cleanly from drought, soil, trade, or panic. Every unusual storm is blamed on the ring, including storms it did not cause. After several seasons, patterns begin to emerge. Farmers compare fields on opposite sides of the maximum shadow belt. Seed suppliers move planting dates and offer varieties suited to cooler or shorter seasons. Greenhouses spread where winter light has become unreliable. Irrigation plans change as rainfall changes. The effects are not uniformly disastrous. Some hot regions gain relief from extreme seasonal heat. Some crops perform better. Pests lose territory in one place and invade another. A region that benefits for 10 years may suffer when ocean circulation catches up. Governments publish ring shadow forecasts beside temperature and rainfall. The maps become as ordinary as storm tracks. Energy systems adapt as well. Solar generation now has a predictable astronomical dip layered beneath unpredictable clouds. Grids move electricity across wider distances. Storage expands. Wind, hydroelectric, and nuclear power become valuable for a reason no planner had included before noon on August 11th. The ring has become part of Earth's radiation budget. That phrase sounds abstract until a family notices bread costing more, a reservoir filling later, or a favorite fruit arriving from a different continent. Architecture responds first with improvised fabric. Hotels install blackout curtains against the bright band. Apartment residents tape cardboard over bedroom windows when sunlit rock remains visible after sunset. Dark sky towns adopt stricter outdoor lighting rules, trying to preserve what little true darkness remains. Then, permanent designs appear. Bedrooms face away from the ring's brightest seasonal position. Roofs incorporate adjustable shades. Public plazas are aligned with the arch, turning the unavoidable object into a civic axis. Railway stations display the current shadow latitude beside departure times. Observatories suffer a more complicated fate. The ring blocks and brightens part of the sky, leaving a moving foreground across fields astronomers once treated as empty. Telescopes schedule around its darkened sections. Software masks the band. Some surveys migrate toward latitudes where the ring sits lower. Astronomy does not end. It acquires a permanent obstruction. Tourism blooms almost immediately. People travel to the equator to see the ring collapse into a razor-thin line. Others go north or south to watch it broaden. Mountain roads become crowded on clear evenings when Earth's shadow begins swallowing the bright arc. Air travel changes less dramatically than frightened passengers expect. Aircraft remain thousands of kilometers below the rock. The dangers are diverted flights, overloaded airports, distracted crews, and occasional navigation outages, not stones falling through passenger cabins. The ring also becomes a tool. Its plane reveals the celestial equator. Its angle above the horizon offers clues to latitude. It cannot provide longitude, and clouds can erase it, so it replaces neither compasses nor satellites. But sailors, hikers, and school children learn to read it. A generation raised beneath the band begins to find old photographs unsettling. The empty sky looks unfinished. The first anniversaries commemorate fear. The lost spacecraft, the failed harvests, the weeks when nobody knew whether the shadow would keep expanding. Later anniversaries become local. Equatorial cities hold festivals beneath the thinnest view of the ring. Communities near the shadow's seasonal limit gather for its arrival and retreat. Religious calendars absorb the moments when the illuminated band passes into Earth's shadow. Languages gain new directions. A house can face ringward. A storm can come from beneath the dark arc. Children distinguish the pale morning side from the copper evening side before they learn the names of planets. The ring changes privacy as much as ceremony. Lovers meet beneath it. Protesters project symbols onto low clouds under it. Governments place monuments where its arch frames official buildings. Not everyone accepts the new beauty. For people who remember the old sky, the ring can remain a wound. They remember stars crossing uninterrupted from one horizon to another. They remember darkness without a shining road through it. For their grandchildren, that grief is difficult to imagine. The band is not an event, it is geography. Culture settles around the same physical rule as weather, and spacecraft, the rock remains in the equatorial plane. Human meanings multiply, but the ring does not respond to them. It shines over celebrations and wars with equal indifference. Long before this imagined day, Earth may have worn a ring once before. In 2024, scientists proposed that a large object passed within Earth's Roche limit about 466 million years ago, broke apart, and formed a temporary debris ring. The evidence is indirect. 21 known craters linked to an ancient impact spike lie within 30 degrees of the reconstructed equator, alongside unusually abundant meteorite material and sedimentary rock. The researchers suggested that debris may have fallen from an equatorial ring over millions of years. Nobody observed that ring. Its existence has not been proved. Its dimensions are unknown, and the idea that its shadow contributed to later cooling remains speculation. But beneath the modern ring, the hypothesis acquires a haunting shape. Geologists search the equatorial belt for the slow rain of new material. Instruments record dust spiraling down. Most small particles burn high in the atmosphere, producing meteor trails concentrated along paths connected to the ring. The ring is long-lived on human timescales, but it is not perfectly still. Particles collide. Some spread outward, some fall inward. Every meteor is a reminder that permanence can be made from continuous loss. Far in the future, a thin layer of extraterrestrial rock may enter Earth's sediments. The sky will leave a line in the ground. After several generations, Earth is still recognizably Earth. The moon remains. Oceans still answer its tides. Clouds still hide the sky. People still commute, plant, trade, argue, pray, migrate, and fall in love. But the map of advantage has changed. Low orbit is precious because it lies beneath the stone barrier. Routes to higher space are political and expensive. Agriculture follows revised light seasons. Energy networks anticipate the traveling shadow. Cities market their angle beneath the ring as once they marketed rivers, mountains, or climate. The ring has not given humanity a single future. It has widened old differences. Wealthy regions build storage, controlled agriculture, and new launch systems. Poorer regions may endure altered rainfall with fewer protections. Countries newly favored by launch geography gain influence. Communities under the strongest shadow demand compensation from nations that share the spectacle, but not its cost. Beauty does not cancel consequence. That is the answer to what happens if Earth gets rings today. We do not simply receive a grander sky, we inherit a new piece of planetary geography, one that reaches into orbital access, weather, food, architecture, and memory. And because it is overhead, nobody can place it outside the story. On a December morning many years later, a school in the northern subtropics opens its courtyard before lessons. A brass strip in the paving marks the farthest reach of the annual ring shadow. The children wait in ordinary winter sunlight. Above them, the rocky band stretches from horizon to horizon, broad and pale against the blue. Then, the light softens. The shadow edge reaches the courtyard. Solar panels on the roof adjust their forecast. Greenhouse vents nearby change position. A bell sounds, and the children step across the brass line. None of them has ever seen an empty sky.